Now let's look at some of the parts of the sky that are important in the Vedic chart. We're standing on the North Pole and we're looking at the horizon. This is the horizon. And then we see here is the ecliptic. Remember, the ecliptic is where all the planets orbits and where the sun is also found. It's called the ecliptic because all the eclipses occur there. There's a part of the ecliptic that is ascending over the horizon. And guess what that's called? The ascendant. And there's another part of the ecliptic that's descending over the horizon, and that's called the descendant. Similarly, the part of the ecliptic that is at the lowest point below the horizon is called the Imam Coeli. And the part that's at the highest point above the horizon is called the Medium Coeli. The MC, or the IC. You'll see these abbreviations in certain astrological charts. Then we have the zenith and the nadir. The point directly overhead is called the zenith. And the point of the sky that's directly under our feet is called the nadir. So any place that we go on the earth, the sky is going to have these different features. The descendant is generally going to be in the western part of the sky. And the ascendant is generally going to be in the eastern part of the sky. Similarly, the Imam Coeli is going to be in the north, and the Medium Coeli is going to be in the south. The zenith is always going to be straight up overhead, and the nadir is always going to be right below our feet. The meridians, whether they are of celestial longitude or earthly longitude, are always going to be great circles. Similarly, the celestial equator and the ecliptic are also great circles. What does that mean? That means they occupy the greatest amount of radius on the projection of the sky. See, we could also have a circle that cuts off this part of the sphere of the sky, but that wouldn't be a great circle. It's only a great circle if it goes through the zenith and the nadir, through the north and the south point. And the center of the circle is identical with the center of the earth. That's a great circle. So we should know that all these are great circles. Meridians, the ecliptic, then the celestial equator. Okay, so these are the parts of the anatomy of the sky. The planets move along the ecliptic, or actually this way. And they follow the ecliptic path, whereas the stars move parallel to the celestial equator. Why is that? Well, because the Earth rotates around its equator. And remember, the equator is just the Earth, the coordinates projected out onto the sky. So the stars appear to move from west to east in a circle around the celestial equator. Whereas the stars, although they follow the planets rather, whereas they follow the stars in their daily motion, over time they move on the ecliptic and they actually move backwards compared to the rotation of the Earth.
Only the planets, right?
Only the planets. Planets and the sun and the moon. Well, in Vedic astronomy, the sun and moon are also considered planets, graha. That's why I like the word graha, because in English, the sun is a star, the moon is a satellite, you know. And what is Rahu and Ketu? They're just points, you know. Yeah, but in Vedic astrology, they all come under the word graha, so it makes it very simple. Because believe me, if you don't understand this stuff very clearly, you're going to be confused later in the course.
Does Earth wobble factor in Jyotish?
The Earth wobble is so tiny that it really doesn't make any difference in Jyotish.
What is wobble?
The wobble is the wandering of the Earth's pole. I mean, unless it wobbles so much, you know, that it changes that it changes the rotation of the Earth. Right now, the wobble is much less than 1 second of arc, which really doesn't make a whole lot of difference.
The ecliptic is so important because this is the only space in the sky we can actually observe, because we need the sun's light, which goes past the Earth to see. Is that right?
Not exactly. I'm not quite sure what you're getting at here. Of course, the planets only shine by reflected light. The sun is the only body that actually emits light. So the sun is really special.
Is the relationship between ecliptic and celestial a sine function? Does it also oscillate?
It does over a period of 27,500 years. But we don't need to be concerned with that on a daily basis for astrology readings.
Why did you say that in this picture we're in the North Pole?
Oh, because the distance between the horizon and the ecliptic is 23.5 degrees. If you're on another part of the planet, then both the celestial equator and the ecliptic are turned. Yeah, the fact that the celestial equator is identical with the horizon here indicates that the point of view of the observer is from the North Pole. The North Pole is the only place, or the North Pole and the South Pole are the only places on the Earth where the celestial equator and the horizon are identical. Any place else on the Earth, the celestial equator will have some inclination. And of course, the difference between the ecliptic and the celestial equator will always be 23.5 degrees, wherever you are. Yeah, it's very confusing. That's why I asked if there's any questions. Remember, the celestial equator is simply a projection of the Earth's equator out into space. Whereas the ecliptic, here's the ecliptic, is actually the plane of the solar system where the Earth's orbit and the other planets' orbits exist. Okay. So, then, let's say we're standing on the North Pole. Right? So, straight up over our head is going to be the North Celestial Pole. Right? And if we're standing on the North Pole and we look out at the horizon, where's the horizon going to be? Straight out here, right? So the horizon and the celestial equator are going to be parallel. That's the only place on the Earth where that is so. Let's take the most extreme other example. Let's say we're standing on the equator. So now, if we look straight up, what are we going to see? The celestial equator. And the North Pole is going to be on the horizon. See, the descendant is and the ascendant are on the horizon. So this picture assumes that the horizon and the celestial equator are identical. The descendant is where the ecliptic and the horizon meet. The ascendant is where the ecliptic and the horizon meet. The ecliptic and the horizon, not the ecliptic and the celestial equator. The ecliptic and the horizon.
The horizon?
Yes.
Which horizon?
The whatever horizon you're at, wherever you are. But like I said, this doesn't show a distinction between the horizon and the celestial equator. Therefore, this assumes that you're standing on the North Pole. Or South Pole. No, North Pole, because the zenith is north. And Florian says, when we see signs rise in the east, is that the ascendant? Yes, that's exactly what the ascendant is. When a sign rises in the... Remember, all the signs are along the ecliptic. We'll get into that when we talk about the Rashis next.
The signs or the grahas?
The signs and the grahas. Okay, if we were on the equator, this whole thing would be turned 90 degrees. Okay?
It would be
No, the zenith is still on the top.